Hello, everybody. Today we're going to be talking about ball on ramp 2 experiment. This is also known as the kinetic energy experiment. So what we've learned so far this unit is that we have kinetic energy, potential energy, thermal energy, all these different types of energy, right? And when a ball is on a ramp, it starts on the very top with a lot of gravitational potential energy, and then it rolls down. And when it rolls down, all of that potential gravitational energy is transformed to kinetic energy. And the more kinetic energy it has, maybe the more velocity it's going to have. All right, so we're going to be talking about that today. Now, there's a video of just the experiment, but there's this video as well to kind of explain some of the data table, because the data table, there's actually 3 data tables, and I would like to explain how you do that. Okay, so in this experiment, we can go ahead and watch it real quick on the side here. Basically, the setup is pretty similar to the ball and ramp. We have here, we're starting the ball from different spots, but instead of measuring the distance that it's traveling, we're measuring the height, okay? And what we're measuring is we have this little tool over here that has a photo gate that measures the speed, and instead of using a racquetball, we're using a marble, okay? So what we're changing is the starting height, and what we're measuring right here is the speed. Cool? Cool. So it will look a little something like this. When we do it, ball comes down, it goes through the photo gate, and then that's that, okay? And then that right there shows us the speed. And we write it down, we do 3 trials for each, you can calculate the average, all that sort of stuff, okay? So independent variable is we are changing the height, and then we are measuring the speed. That's our data table, and you can find that data table in 2 different spots, okay? So part 1, part 2, you know how to do that, but I want to go about part 3 because there's 3 data tables and it looks really confusing. So the first thing that you'll notice is these starting heights, okay? And these starting heights right here, we measure them in centimeters, okay? But in order to use this equation that we used last class, this m times g times h, we need to get them in meters, okay? So to do that, we divide it by 100. So 67.3 becomes 0.673. This one would become 0.528, and this would become 0.374, and this one would become 0.2046, and this would become 0.123. So the first step is dividing by 100, okay? Now the next step is we want to figure out when the ball started, how much gravitational potential energy it had, okay? So we also need to know the mass of the ball. Well, I took the mass of the ball, of the marble actually, and it's 28.32 grams. You don't see that in the video, but I give it to you. But in our m times g times h equation right here, our mass isn't in grams, it's in kilograms. And in order to get these grams, this 28.32, we have to divide it by 1,000. Okay, and when I do that, it's like moving at 3 spots. I go 1, 2, 3, and I get 0.02832. Okay, cool. Now, the last thing I do is I need to calculate the mass times the gravity times h. Well, the gravity we know is 9.8. So what I'm going to do is I'm going to take this number, multiply it by this number, and multiply it by this number to get this one. Okay, so if I use my calculator, I'm going to go 0.673 times 0.02832 times 9.8 equals, and I get 0.186. Okay, and I'm going to do that all the way down. Really, the only number I'm changing are these numbers right here. All right, I'm just putting 0.528 times this equals this. 0.374 times this equals this. 0.2046 times this equals this, and 0.123 times this equals this. And that gives us the potential energy of the ball, of the marble at these different heights. Now let's think about this for a second. The potential energy that we have up at these different heights will all be transformed into kinetic energy, okay? We're gonna assume that there's no friction and thus no thermal, okay? So the next thing that we do is we are going to just get the averages of our speed. That's where this data table comes in right here. 0.3, 70, 0.3741, bam. So you just take the average of these three, get the average. Also calculate the uncertainty. Average of these three right here, calculate the uncertainty, average, uncertainty, average, uncertainty, average, uncertainty. Okay, so the last data table, we don't do any more calculations, we just copy. Okay, so in position 1, that started at 67.3. So we can go right here, position 1. Okay, we can say that the velocity was whatever we got right here. Okay, I'm actually going to do that just to kind of show you an example. So if I have 0.370 plus 3.741 plus 3.715 equals divided by 3, bam, 3.72. Actually, we can use one more thing, 3.719. This number right here is what's going right here. So the green column goes with the green column. And the kinetic energy, what I got right here, goes right here. Okay, so let's talk about that. Right here, we calculated potential energy, but here it says kinetic energy. Well, look at this. The kinetic energy is equal to the potential energy. The potential energy that we calculated right here, mass times gravity times height, went down the ramp and it turned into kinetic energy. So it's the same number. So then, bam, we have that. Now that we have this data right here, we can use this Desmos graph and we can input it. So my first data point is 3.719, 3.719, and this one right here would be 0.186. So there's my first data point. Cool? Cool. Any questions? Well, this is being recorded. Shoot me an email. Remember, you also have to do all this kind of stuff right here. This is a big one. So if you pass this lab, I will give you credit for all your other labs. So this is the most important lab, but it takes a little bit of time. Okay? Thank you for checking in. I will see you guys later. 2 more days left. You got this.